What's the matter with gravity? I'm not actually asking the question you might think I am. Matter is all around us. It's just stuff. The stuff that we're made of, the stuff this room's made of, and it's mostly building blocks called atoms. But did you know that all this matter was once inside a dying star? When massive stars explode, they give out lots of energy. In fact, they're brighter in that moment than all the stars in their galaxy combined. What's left over is sometimes a neutron star, a star that is so dense, has so much matter packed together, that if you took our sun and you crushed it to the density of a neutron star, it would fit nicely inside the 11 bus route around Birmingham. But it's really, really dense so that we actually can't recreate those densities here on Earth. The atoms themselves have been crushed, and they leave behind matter called neutrons, which we think might be true, but we also are not sure what matter there is there. When we can't bring neutron stars here, and we can't create densities here on Earth like that, how do we actually know what the matter is at high densities? And that's the question I answer in my research. Now imagine two neutron stars spiraling in together and colliding in an explosion. But this explosion now in that moment is brighter than the entire observable universe put together. But not in light, in gravity. It sends out waves in gravity that travel towards us at the speed of light and pass through us. And if that's happening right now, then the space around us is wobbling, the space inside us is wobbling. But luckily we don't notice it, it's too small. We can measure it though, and when we get a signal, it looks something like the orange data that I've shown on the left. This is space changing over time. And you can see that the data is pretty noisy, but there is a wobble there. Encoded in this data is information about neutron stars, including how squishy they are. Squishy neutron stars, like the green one above, they stay quite spherical as they spiral into each other. But more rigid neutron stars are forced to deform, like the purple one below, into a squashed sphere. And how much they deform is directly linked to the matter inside, because it could be matter that we've seen before, like neutrons, but it also could be matter that we've never seen before. This is completely uncharted territory. So if it is matter we've never seen before, this really might change our understanding of fundamental physics and the building blocks that we think our universe is made of. During my thesis, I have actually made a model which maps how much the neutron stars are deformed to what the signal should look like. This means that when real data comes in, we can play a game of snap, matching up the model to the data to see how much the neutron stars have deformed and therefore what the matter is inside. So using my model, we can figure out, using gravity, what actually the matter is inside the neutron stars. Or back to my original question, when it comes to high densities in neutron stars, how can we figure out what is the matter with gravity? Thank you.